Alright, here is a video on long division and rational functions, and I'm taking this from the worksheet, long division and rational functions. And what I want to do is I would like to do problem number 4 because I think that problem takes everything into effect that you might have thrown at you in a problem like this. So what we do is we start off here with a rational function, and this is a rational function that's in a form where it isn't entirely clear what the vertical dilation is, what the vertical shift is. We're pretty clear on what the horizontal shift is. What we're going to have to do is we're going to have to do some division here in order to put this into transformational form. So I'm going to rewrite it this way. What we're trying to do is we're going to divide x minus 5 into 2x minus 7. And I say to myself, how many times does x go into 2x? It goes in twice. And so 2 times x is 2x. And 2 times negative 5 is negative 10. I'm going to subtract this entire polynomial right here. I'm going to put a minus on the outside. 2x minus 2x, I get a 0x. Remember though, we're distributing this negative through. So a minus 10 is a positive 10. 7 plus 10 is going to give me a positive 3. And so my final answer is, how many times does x minus 5 go into 2x minus 7? It goes in twice with 3 x over 5s left over. It goes in twice with 3 x minus 5s left over. And the form that we're used to is this form. It's really close, but typically we look at it this way. f of x equals 3 over x minus 5 plus 2. Now we can see the shifts and the dilations really clearly. So let's describe how the parent function was transformed and write the equations of the new asymptotes. All right, how is it transformed? Number 1, what does that 2 tell me? The 2 at the end tells me, right here, right here, that 2 says we're going to shift up by 2. So it's a vertical shift up by 2. And what happens down here, can't even see my cursor, there it is. That tells me that I've got a horizontal shift of 5. All right, so horizontal shift by 5. And remember, we always do the opposite of what it says here. And so that's going to be by 5 to the right. Okay, and lastly, what's happening here? What is that 3 telling me? That 3 is telling me that I have a dilation or stretch by 3. All right? And now I need to write the equations of the new asymptotes. All right, typically, where would I see my asymptotes? My asymptotes would be, let's get back in here. My asymptotes would be the x and the y-axis. But wait, I have been shifted up. So what I'm actually going to do before I write my equations is sketch them in. All right? And let's get back to red here so that we can really see this. I'm going to sketch in my new asymptote. I've been shifted up by 2, vertical shift up by 2, which means instead of it being the x-axis, it's now this line right here. And what is the equation of that line? The equation of that line is y equals 2. And remember, we've been shifted to the right by 5. So shifting to the right by 5 means the asymptote is going to move to the right by 5. So I always do this. I always sketch in my asymptotes, because basically it's going to give me a new set of axes that I can put my function on. All right? And so what is that? The equation of that line is x equals 5. And let me get it back so you can see it there. That's the line x equals 5 right there. All right? So I've written the equations of the new asymptotes. I've given the description of what's happening. The last thing we need to do is graph the function. Okay, so I'm going to scoot over a tiny bit here. We're going to lose the equations of our lines. I need to sketch this in, and when I sketch it in, what I do is I come back over here. I can't quite see my cursor. Here it is. All right. Normally, I would have a function that goes through these points. Right? It goes over 1 and up 1. But wait a minute. Remember, we have been stretched by 3. What does that stretch of 3 do? Typically, a function would go relative to our new asymptotes, over 1 and up 1. But when I have a stretch of 3, I now will be going over 1, up 3. And I can also think that of going over 3, up 1. So I put these in my new positions, and this is going to be my new function right here. And I draw that function in, and typically what I do is I just have it coming off of my asymptotes pretty close through my vertices. Whoop, and that was not a particularly good one right there. It would be more along those lines right there. And I'm going to get rid of those final vertices. Alright, because those are definitely not part of this function. Not part of our function right there. And I'll get rid of that line. This is our new function right here. Seems I can't erase that line. And just so you know, what is the actual vertex right here? What are these points right here? It turns out that this point right here is the square root of 3, the square root of 3. And if you want to label those as well, you can. But typically we put down the actual integer values of the vertex right there at 3, 1, 1, 3. And that's it. We've included our asymptotes and our vertices in the graph. And that basically talks about everything you need to know in order to solve one of these problems.